In this lesson, we're going to look at how we graph with Excel, but this time we're going to look at how we plot an inverse relationship and what adjustments we need to make to those values in order to obtain measurables in the same way as we did beforehand. In this example, we're going to look at a different type of relationship. Rather than one that was just straight values given that we would use a scatter graph for, we're going to do what's called an inverse relationship and how we would deal with an inverse relationship within Excel. We've got data from a practice question that compares photon energy and wavelength. And we're going to plot a scatter graph to represent this data in the space below and then describe what we can see in this graph. So like before, I'll highlight the data, go to Insert, and then pick my scatter graph. Now, in this case, I'm going to put a curve on it. So I'm going to put the smooth lines and markers in, because if I put just the values in, it doesn't help me as much. So I can use either of these two values here. I'll actually just use this one, and I'm going to put it in. Now we should adjust, our title. So this one's a line graph now, comparing photon energy and wavelength. I don't know if making this any smaller will fit it on one go. And then I put on my axis titles. So the horizontal one, you can see, goes up to 2500. So that one must be the photon energy. And the vertical one must be the wavelength. Okay, you can see that we definitely do not get a graph that can be described in any way, shape or form from what we had beforehand. We can say, well, what could we say about our little graph here? So I'm going to change my alignment so that at least it makes sense. I'll say it's kind of an upside down graph. But I could also say it shows a sharp drop off as we increase the photon energy before leveling out. So it kind of goes a bit straight. And this is what an inverse relationship looks like. And as it is, well, apart from it being a quite ugly looking graph, we can't really get very many measurables out of it. So we're told that the relationship between the values is an inverse relationship, and we're going to write a formula that changes the values so you get a straight line. Now if I show you what the graph for an inverse relationship looks like, it's y equals k, which is some value, some number, over x. And you'll see that as opposed to what we plotted before, we just plotted y is equal to x beforehand. So we plotted our x values and our y values against each other at the moment. That's what that graph looks like when we plot a y equals x. But if we want to plot y equals k over x, well, the y bit doesn't change. We're just going to keep our y values the same, or in this case the wavelength. But we are going to change our x values, and instead of being x, we're going to write it as k multiplied by 1 over x, where our gradient of our line is going to be k, and we're going to plot 1 over x. So our x values were the photon energy. So I've given you a bit of space here at the side to say, right, I'm going to do 1 over the photon energy here, which I'm going to call PE. So if I do that, it'll be equals 1 divided by, and then I can just click the photon energy button, and I'll get a new value. If I click and drag down, it'll assume that I'm using the 100, it'll assume that I'm using the 1000 and the 2000, and I will get a new table of values. Now when I go to plot a new scatter graph and include the equation of correlation value before, I'm going to separate this value, this table out to the side to make it easier to plot, like so. And I'm going to select this data, and I'm going to do my scatter graph. Now when I do my scatter graph now, I can do it without the line. I can just do my points, but you will see that that now makes a straight line, that relationship. And let's do it. Let's do what we did beforehand with the scatter graph. I'm going to put this in, and I am going to label it up. So graph, or line graph, or scatter graph it really is, isn't it, at the moment? Scatter graph comparing photon energy and wavelength. I can spell, I just can't type as it turns out. Okay, and I can put my labels on. So my axis title for this one is now not photon energy, but 1 over photon energy. Which, if you remember from your indices, will be j to the minus 1. And vertically, I'm going to keep this as wavelength. By 10 to the minus 3, as it says in the bit. Now, if I wanted to do what I did beforehand and stick in a trend line, a linear one will make a nice black line that's not dashed, and we put in our equation and our correlation. You will see that our correlation is exactly 1, or that each of these points lie exactly on the line. Now, I can't promise that even if this was experimental data, that this will always happen, because depending on the experiment, things can get in the way, but you should see a strong correlation. If you've been told that the relationship was inverse, then you should see this kind of example. Now, getting you to do the same thing, I have another set of energy and another wavelength, and I have going to ask you to do the same thing and put it together and draw a new graph and try and get a straight line and try and obtain what the value of the equation should have been. So y equals 0.0805 x plus 7 by 10 to the minus 6, or otherwise. It's a very slight, it should really go through the 0. In this case, I maybe could have even set the intercept to 0 and given you what that was. But in any case, we have got that right there. Any problems, you can let me know.